in these set of videos, I'll have few examples where we'll try to identify the polynomials from the graph, write their characteristics, and provide some information so that we can actually write the equation. So here's the first one. It says, write characteristics of the given polynomial. So this is the polynomial given to us. We need to write its degree and behavior, number of zeros, number of turning points, and symmetry. So as you can see from the graph, the degree we're not very sure about, but we can say one thing about it, that is even degree, right? So we can say even degree. And of course, this flatness shows that the order of 0 is very high here. It is not just x squared type, right? So there are zeros at x minus 2 and x plus 2, and it seems that x plus 2 and this one is x minus 2. The degree of these is more than 2. It could be 4, it could be, 6, 8 or something like that. But it's definitely, from the flatness, it is more than 2, right? So this function is at least 4th degree, but it is higher than 4 degree. Correct? That is what we can know from here. And if we provide you information of this point, which is the y-intercept, then actually you can find the function. That is, the function will be a times this, provided we give you this point, right? In that case, you can actually find the function. And let's go ahead. End behavior. End behavior is what happens when x is approaching minus infinity and when x is approaching plus infinity. As you can see from the graph, if x approaches minus infinity, y approaches plus infinity. And as x approaches plus infinity, y approaches plus infinity. It's an even degree function with leading coefficient positive, right? Therefore, you see both sides up, right? You can add that leading coefficient positive from the end behavior itself. So we can write an is positive. Now, number of zeros. So we have only 2 zeros here. Number of zeros is 2. And their order is even. Order is even. Even because the graph bounces back. Number of turning points, you can count 1, 2, and 3. And symmetry is even symmetry. Note, all even degree graphs will not have even symmetry, right? Even symmetry means that it is symmetric about y-axis, right? And it also means f of minus x is equals to f of x, right? So that is how we can work on this and get some details. Now, if I provide you this point, that this point is actually 1.5, then as an exercise, find the equation of this graph, right? In this form, okay? Thank you.